Thank you for inviting me. My name is Joonathan Mägi. I spend my days building platform for global mobility platform at Topia. We previously were actually 3 separate companies, MoveGuide, Teleport, and Polaris Global Mobility. And we're catering and building software as a service platform for HR workers, mobility professionals who actually move people from one country to another. So some of our customers are really big corporations like Wall Street banks, some startups that you maybe every day use like Slack, that hire from abroad. So continuous delivery is something that we necessarily care about, somewhat due to our customers as well. So if we say continuous delivery, what do we actually mean? The usual definition is that you should be able to deliver your software, to deliver your changes, get that to the hands of the users that you're catering for. Whether that means that you ship into production, maybe it's something totally different, but that's the continuous delivery. And that it needs to be quick, safe, and sustainable and repeatable as well. So you want to keep on going with continuous delivery. But before you can actually do continuous delivery, you need to understand that there's a side called continuous integration as well. And that's the side of automating your software build processes, automatically testing even before you actually start to try to roll something out. You need to be sure that the version, the build that you will try to roll out is actually of a high quality. And with continuous integration, we try to avoid having developers build software in their own personal laptops for a long time, and then at some point, very close to a release, start to integrate that back. Continuous integration, we always want to be shipping. We always want to get the code that the team member develops actually to the version control as soon as possible, maybe to the master branch, whatever your development methodology is, but keep that pace already from the get-go. And continuous integration is actually the part that starts the continuous delivery process. That can mean that it kickstarts some of the pipeline stages that come next after. Maybe your continuous integration pipeline already does some integration tests and then whatnot locally. Maybe your continuous integration uses Jenkins, Circle CI, whatnot. But we want to keep that process going and then take that to the continuous delivery. And in the end, roll that out to the actual users. Whatever that is. Might mean different environment, might mean that we actually deploy to production in the end. It's not necessarily the one truth for all of us. And we're going to be looking at one of the software platforms that allow to do that. Spinnaker is an open source, multi-cloud, continuous delivery platform. Its core focus is the delivery part. It's not trying to replace Jenkins, not trying to replace Circle CI. And of course there are many alternatives. Like we heard today about Kubernetes operators. So if we solely care about continuous delivery on Kubernetes, we want to be hip and happening, we care about GitOps, then maybe Waveflux is something to look at. It's operator-based continuous delivery GitOps way of doing things as well. But if we want something battle-tested, reliable, then Spinnaker is one way to go. It's started at Netflix at 2015, around VMs. It's been open source since 2017. Netflix continues to be one of the core committers, but another big user of Spinnaker is Google. So they're heavily committing and making sure that it's stable and battle tested as well. And Google is using it internally. Netflix is continuing to use that. Like some of the software that you might use every day, like for example Waze, rolls out using Spinnaker. So what does Spinnaker actually offer? Spinnaker integrates with different CI systems. So you can kickstart the continuous delivery part from Jenkins, for example. It can integrate with your monitoring systems. So if you want to make a note when the deployment happened, maybe to Datadog, maybe to Prometheus, whatever it might be, there potentially already is an existing integration for that. It has very good access controls and role-based access controls as well, especially important in the enterprise environments when you want to be sure who can do what, who can trigger some build processes, who maybe needs to approve something to go live, and so on. It can integrate with Google Apps, LDAP, pretty much whatever you can come up with. Of course, it has built-in notification engine, whether that's email or your favorite Slack chat, it most certainly can do that. If you are triggering the build processes as you should be from the CI, it might not be always a good time to release. So Spinnaker has an understanding of whitelisted execution windows as well. So maybe you have only very specific time where you can actually do a rollout. Then you can make sure that Spinnaker understands that this is the time and it doesn't really try to do anything unless in this whitelisted execution window. And it has multiple deployment strategies. So whether it's Cannery rollouts, blue-green, whatever you pretty much can come up with, Spinnaker probably supports that. The caveat there is that Spinnaker supports those deployment strategies for a limited set of ways that Spinnaker supports. So for example, Kubernetes being one of the cloud providers, so to say, it supports that for AMI and auto-scaling group-based deployments on AWS, Google Cloud, and so on. But it's not your average trigger Ansible script or do something like that type of engine. So it has its own drawbacks as well. So maybe out of the box it can't actually handle all your deployments if you're doing something weird. As it's from Netflix it of course has a Chaos Monkey integration as well. So to be sure that you would stay up if any of your pods or instances go down, Spinnaker can actually chip in there. And manual judgment. So ideally, continuous delivery happens automatically. So you ship quality code into the repository, something happens, it's tested, it's deployed to some test environments, tested there, and then rolled out to production. That might not be the case for all of us here. So if there ever needs to be a manual step, you can have roles-based access to that, and then someone just goes in and pushes the button and says, yes, let's go, let's deploy. So what are we going to look at today? And I'm going to be quite well-paced going through that. But we'll actually have done a lot of preparation as it's already 9 p.m. We're going to set up a cluster, Kubernetes cluster, and we're going to use Google Kubernetes engine for that. We're going to set up some prerequisites. We're going to use the Helm Kubernetes package manager to actually deploy Spinnaker to that cluster. We're going to use Google Cloud Builder to actually be the CI part of our pipeline. And we're going to set up Spinnaker pipeline to actually do Cannery-based rollout from that. So you might be using something totally different. You could be using COPS to set up your cluster. You could be using AKS, you could be using X. I just chose Google Container Engine for this demo, and I have prepared and set up a demo cluster here as well. Some of the prerequisites, we're going to create a Google Cloud IAM service account for Spinnaker. We're going to create a pub/sub topic where we can actually subscribe to the Google Cloud Builder. So on all the successful builds, we can have Spinnaker listen to that observed queue and then trigger our deployments from that. Not all of you might have Helm installed locally. This is the way to get Helm on Mac. Helm is the package manager for Kubernetes. We heard about Helm in the first talk a little bit about as well. It should be really looked at as a package manager, installing third-party packages. You necessarily shouldn't be using that to ship your own code. It can be tempting, but you end up realizing that it might not be the best fit for that. So how can we actually get the Helm first installed into our cluster, and then getting the Spinnaker installed as well? Helm relies Kubernetes service relies on a Kubernetes service part of that Helm package, Tiller. So first we actually deploy necessary prerequisites for that into our cluster. And then using the same Helm CLI utility on our own machine or wherever, we actually initialize Helm in our cluster. And we're going to create some Google Cloud buckets where Spinnaker can actually store its configuration. And we're going to install Spinnaker using Helm. This usually takes like 5 to 10 minutes if you try that, so it's not very easily presentable as such. And when we are lucky and it completes, we can actually, by default, it's only exposed as an internal service, and then we're not going to create a load balancer or anything for that. So we're going to use the kubectl report forward and then forward ourselves to the Spinnaker dashboard. And we're going to take a look at that later on. To prepare our pipelines, we're going to need a Spinnaker utility called Spin. Very easy to get. It's a single binary. You install it and get going. I have actually prepared Spinnaker application pipeline as well. It's a JSON definition, but actually you could do the pipelines within the Spinnaker console yourself as well. So it's actually quite a nice dashboard, and this is how it would actually look like. And shortly we're going to take a look at that as well. And our pipeline actually, what it does is that we're going to roll out first. We're going to wait for a trigger. So we get the trigger from the Google Proofs app after the Google Cloud Builder has finished the build and successfully completed. We'll wait for the trigger. After that, we will deploy a Cannery instance of our backend and front-end service. And we're going to have a manual step here in between, so we could verify that we are good to go to production. And after that, we're going to do a Kubernetes default gradual rollout of, into the production as well. We're actually, as we do in Cannery, we're just extending the rollout to more instances. So I have set up a Google source repository, Google Cloud source repository, and as I mentioned, we're going to be using Cloud Build. So Cloud Build, similar to Jenkins files and then whatnot, has a YAML definition of what the steps are, what you should be doing. So here it's a very simple Go project. We're just going to Docker build it. We're going to test it. We're going to copy the Kubernetes manifests into a separate Google Cloud Storage bucket so that the Spinnaker could access these. And that's not a requirement. Spinnaker actually could get the manifests from multiple different places. So GitHub, S3 buckets, whatnot. You could actually even hard code these into the pipeline. For the cloud build, we're going to build a trigger. In this case, this is the trigger to initiate the build. It's going to listen, it's going to watch the cloud source repository. It's going to watch for tags, so we don't, on every git push, we're not going to do everything here. We're going to watch for tag pushes, and it's going to read the cloud build YAML from the repository and do its build from there. For the Kubernetes manifests, we're going to use another bucket that's version bucket, so we can actually go back in time as well if need be. So let's take a quick look how that all is looking in reality. If I find my mouse, so here we go. So this is the source repository. It's a Git repository as any other. This is the cloud build. This is the trigger. Very similar to the setup that I just showed. And we can see that I've actually done a few builds from this repository already as well. And Cloud Builder gives us an overview, logs, everything very similar to Jenkins. So this is a quick demo, and this is a hosted service. It's pretty much free to use. You get like 3,000 build minutes per day or something magical like that from Google just to do your builds. So this is very, very simple to get going. And as you can see in the end of the build, there's an artifact, let's call it an artifact. It's a Docker image created with the content addressable SSH hash as well. And this is Spinnaker. Spinnaker has understanding of Kubernetes as such now as well. It's using weird terminology. It's not one-to-one match to Kubernetes terminology. So load balancer doesn't necessarily mean load balancer, it just can mean random service as well. Let's take an application. Our application is the sample application. And we can show that cluster is actually, clusters are actually deployments, so to say. We can take a look at the load balancers. We can see what the load balancer IPs are, for example. And we can see that it's actually serving traffic. And we have a few Cannery instances in there as well. Currently the version, application version is same in the Cannery and the production instances. So it has an understanding of what's happening in Kubernetes clusters. Let's take a look at the pipelines. So we have a few successful pipelines here. We can take a look at the pipeline configuration. This is the manual step. And these all depend on each other. So how do we actually now get it built? So let's open up the terminal. It works. Do a small change here. So we saw that the window was orange. Change it to blue. We're going to tag it as we were looking for tags. And we're going to push it. And of course, the tags here is again arbitrary. You could be doing this on every git push or anything else really. So now let's take a look at our cloud builder. We can see that there's an ongoing build. on Cloud Builder. It has picked a new tag there. The Go application will be built. And if it's successfully built, PubSub message will be sent. That will be picked up by Spinnaker. And Spinnaker triggers, again, PubSub is just one way of doing it. It can be webhook. It can actually be polling in Docker registry, looking for new Docker images. It can directly sit on top of some Git repository and look for changes there, and so many different ways, from webhooks to Docker registry monitoring. So no new pipelines have triggered here, so this is probably still building. Let's give it a little bit of time. Using that time, we can actually take a look what's what do we have running in the cluster. So we can see that we have Cannery instances running, we have production instances of the front end and back end running, and currently the Spinnaker itself is running in the same cluster as well. Spinnaker doesn't need to be running in the same cluster. Spinnaker can be deployed to your infrastructure cluster that just purely deals with orchestrating other clusters, for example. It doesn't necessarily need to be exposed to the world at all, depending on what you use it for the triggers. So the triggers reach it. And here in my case, Spinnaker, like the UI side of the Spinnaker gate is not actually exposed to the world. I'm just proxying it using KubeCAD. So let's see if this is getting anywhere. Test completed. And we can see as it completed, Spinnaker has actually already picked up, and in parallel is deploying all the Cannery instances. The Cannery service definitions have already been updated. The Cannery backend service is being updated. You can take a look at the Kubernetes YAML configurations here as well, what the changes are there. And you can see that Spinnaker has an understanding of image as such, like the Docker image that is being used in the YAML file, and it itself has actually replaced the proper content addressable hash that it got via the PubSub message into the Kubernetes YAML that it's actually applying to the cluster. In addition to understanding the images, Spinnaker has built-in understanding of config maps, for example, as well. So Spinnaker by default could, for example, do a version config map and then replace the version config map into your cluster. So if you ever have to go back, the previous config map actually would be sitting there in the cluster. So we can see that all the Cannery steps have successfully been completed, and we are actually waiting for the manual step here. But first, let's take a look and see if what has happened here. So let's quickly take a look at the purely only the Cannery instances. So we can see that indeed it has gone from orange to blue. This is the production instance. Most of the traffic would be on the production version going to the production, but as we are talking about the Cannery release, some of the traffic is already actually pointed to the new version. And this is just done using Kubernetes service definitions. If you want to have more control over it, then you actually could use Istio, for example, to very precisely target who is seeing what, whether the Cannery is only available based on some cookie or something like that, for example. So that looked good. We can go back to our pipelines. And we can say that, yes, let's continue and let's deploy this to production. And again, we can see that the rollout now has started. again, we're doing 4 different things in parallel. And if we take a look at the cluster itself, we can actually see that Kubernetes is rolling out another deployment. And then there's nothing magical. Spinnaker is just using the deployment object of Kubernetes and then doing it as if you would have applied the deployment yourself to the cluster. Spinnaker is making sure that the deployment is stable after that as well, and then we can actually see that now the deployment has been completed. And if we take a look at our production IP address, you can actually see that whether it's serving Cannery or production, it's always blue. So this is the very basic way of using Spinnaker, and we didn't really do anything you couldn't do directly with GitLab or GitHub Stacks or Jenkins itself, Jenkins X or whatnot here. But if you want to have more control over your deployments, if you need to show some of your customers a record who did something when, then maybe none of those tools actually are able to provide that to you. Spinnaker is one of the tools that actually has that, being used in production by many companies. There are also paid support available from many different companies, and potentially there will be an operator running Spinnaker for you at some point as well. Currently, it's still quite limited what you can do with Kubernetes here. For example, if you want to do heavy templating on the Spinnaker side itself, you're limited to using Helm charts, or at least Helm commands for doing that. But actually, Spinnaker has built in quite a pluggable way, so we're actually ourselves at Topia looking at maybe using something else there as well, whether JSON.NET or maybe customize for doing templating. There's basic templating also built in, so you can just use parameterized builds, for example, where you define in the build a parameter that gets replaced into the YAML file. That gets applied. That's the very basic use. As I mentioned, it's not limited to Kubernetes, and yeah. And instead of rolling out from the Cannery in the same cluster, we could have been deploying to a totally separate cluster or even multiple clusters in parallel. So I think that's it. Like this is the way that no one really uses Spinnaker in production. Like, this is if you want to do continuous delivery on a hackathon, and you have 30 or 25 minutes. This is actually what you get done. You can have the checkbox that yes, we did continuous deliver. It's actually very much more nuanced to get it all working. But, Spinnaker can be, like if you look from afar, it can appear as a big beast, like it's a ton of Java code written in many years. But actually you can get going in a quite well-paced manner. Yes, the installation would have to slightly like a 10-15 minutes longer than the presentation was right now, but we would still be completed before it's 10 p.m. I'm happy to take questions. Yes.
That was an awesome talk, and I'm kind of curious about the rollback procedures that are there. Are there any like telemetry analyzers that can automatically roll back the stuff?
What Spinnaker does have is automatic Cannery like detection. So if you're rolling out Canneries and you have defined these as Canneries as such, then Spinnaker for you can look at the telemetry, like whether it's some custom metrics that you expose by Prometheus or whatnot. You can look at that and make sure that, like, for example, your performance has not gone down. The Cannery still behaves as it should be behaving. And based on that, you can remove the manual step, for example, and it gradually continues the rollout. And there again, you can change the pace of the rollout. So maybe it's like a one Cannery instance. Maybe you're rolling out to 20%, 30%, and gradually growing the percentage. I probably would prefer to roll forward if possible. If you want to roll back, yes, there's the version config maps and then stuff like that. But always, like, we didn't touch any like data or state in this. And then what makes rollbacks usually complex is the state changes. Maybe your application is not able to handle that state anymore if you just purely roll it back. If possible, just roll forward. Or use some Cannery ways of doing that, just to stop the actual rollout itself. And
is it like able to compare against the baseline of the production servers?
Yes.
Like just if you see this deviation, then roll back and that kind of stuff.
That's doable, and that actually is in the baseline Spinnaker available nowadays as well.
Awesome.
Yeah. And the Kubernetes integration is now actually already version 2. The initial Kubernetes integration that Spinnaker had was very limited in what it can do, and used its own set of like you had to define pretty much everything on the Spinnaker side. Now you can actually use the Kubernetes templates themselves and continue using that. So that also means that you could use Spinnaker to deploy custom resources, for example, or use Spinnaker to deploy operators, if that was your thing.
That's it.
Thank you.
No questions? And real chocolate?
Real chocolate.
And
Latvian what?
yes, from Rini.
Ah.